For this question, the figure below show a closed cylinder, can of the radius r and height. So this is your variable. Given that your surface area, so we have a constant here, 192 pi. Show that the volume of this cylinder is in this formula. So volume, it will be pi r square h. So it will be its base here, pi r square times h. Then you can see our volume is in terms of r only, means we need to find out what is your h term from your area. Area will be 2 circle with 1 rectangle for this side. So 2 circle, it will be 2 pi r square, and then for this rectangle for the cylinder side here will be 2 pi r h. So we can simplify, as here you can see we want to find out what is your h. So 2 pi r h equals to 2 pi r square, move to the left hand side. So h will be 192 pi divided by 2 pi r, then 2 pi r square divided by 2 pi r. So pi can be simplified. So h will be per r, and then this can be simplified, minus r. So we're going to substitute h equals to 96 over r minus r into the volume. And we try to expand, we see can get this or not. So expand this, we can get 96 pi times r, as this r is cancelled, leaving one r only. So we are getting close to it. Yes, they are same. So after we show this, we read the question for number 2. Find the value r which the v is stationary. So to get the v is stationary means dv dr equals to 0. So from here we want to find out what is our r here. Differentiate from the v 9 pi r minus 9 minus pi r cubed. When we differentiate v with respect to r, 96 pi. And this one we let it to be 0 so that it is stationary, means it is critical. So r squared divided by negative 3 pi. So r will be positive negative square root 32. Since r is a radius, means r will be equals to square root 32, which is 4 third 2, which is positive only. So this is the value of r when it is stationary. Justify this value of r which will give you maximum. So with this stationary or this critical number, we now need to justify, means we need to do tests. We were using second derivative test, d2v dr squared. So differentiate this, we get constant, we get 0. Differentiate this, power move to the front, power minus 1. We substitute the r as 4 third 2. We get negative less than 0. Justify this negative means it is concave downward, so it will give you maximum. Therefore, this R is maximum. So justify the value of R, give the maximum value of V. Then calculate the maximum value of the volume. So when you come to question D, we want volume maximum. We will use the radius maximum here to calculate our volume maximum. So here we have. Then we see how we're going to score this. First of all, 3 marks. So to get the 3 marks, we're going to find out what is your H in terms of R. Substitute to prove this. Secondly, B, find the value of R when it is stationary. So we differentiate that it's 0 to get the value of R. Then to verify it is a maximum, we use second derivative, we differentiate. Then we substitute our R to be test here. So that is your 2 mark. And lastly, your volume maximum, substitute the R that already maximum to get the answer 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Alright, so that's all.